First, we're going to start with a review of torque. So torque is our rotational force, and it's dependent on essentially three things. The first is the size of the force. How big a force am I applying to rotate something? Also, it depends on which way am I applying the force. Am I applying the force perpendicular to the door as I try and open it, or am I applying a force parallel to the door when I'm trying to open it? It makes a difference in how I open the door. Also, where am I applying that force? If I'm applying it at the hinges, that door isn't going to open very well. But if I apply it as far from the hinges as possible, that door is going to be easier to open, or I can create a greater acceleration of that door opening. So those are the three things that torque is dependent on. Now we're going to look at what is that other factor that affects the angular acceleration of that door opening, and that is the moment of inertia. Okay? This is the resistance to a change in rotational motion. For regular motion, linear motion, we talked about mass as being a resistive property. I can apply a force to a small object and it will accelerate much more than if I apply the same force to a large object. So now we're going to see, what is this moment of inertia dependent on? So it's dependent on the size of the mass, same as with linear, but it's also dependent on where is that mass located. Is it located close to the axis of rotation, or is it located far from the axis of rotation? So let me do a quick demo to show this. So here I have a stick with two masses that are fairly close to where my hand is. I'm going to just rotate this back and forth. And you can see that it rotates fairly easily and quite quickly. But if I go ahead and I move that mass out farther away, okay, so I've changed the location of that mass relative to my axis of rotation. So I've increased that axis of rotation. Let's see how easy it is for me to change the rotation. Okay, do you notice how I can't get it to go as fast back and forth? And so what I've done is I've increased the moment of inertia by increasing the distance my mass is from my axis of rotation. So in general, the further the mass from the axis of rotation, the larger the moment of inertia, the larger the resistance to a change in motion. And so our relationship actually comes out that torque is dependent on how far from the axis of rotation. Moment of inertia is dependent on how far from the axis of rotation squared. Okay. Moment of inertia, again, has the capital letter I for its variable and units of kilograms meters squared. Next, we're going to look at how do we actually calculate this I value? How do we get a number for it?